Okay, so for number 55, we want to show whether this sequence here, it is convergent or divergent. And a sequence AN is convergent if AN tends to a defined limit, a number, as n goes to infinity. So we have that our AN is equal to n factorial over 2n. And so because of this factorial, this is a little bit difficult for us to analyze analytically, right? We don't really have the tools to deal with the factorial because we can't really differentiate it. So what we're going to do here is we're going to use comparison with something that we already know, right? And so what we're going to do here to compare, we need to be able to expand it to see its behavior. So this expansion is going to be on the numerator, n factorial is just 1 times 2 times 3 times 4 and so on until n minus 2 times n minus 1 times n. So we're just multiplying from 1 all the way till n, and on the bottom we're just dividing by 2 every single time, right? So divided by 2, divided by 2, divided by 2, and so on. And so all of these are going to have 2 on the denominator. And so using this, we want to compare it to something that we already know, right? And what is something that we already know? Well, what we're going to do here is let's just break this down into two parts. I'm going to break it into the left and the right hand side. And the reason that I'm breaking it down is because when the numerator, it goes to 3, we can see here that the numerator is bigger than the denominator, right? So from n greater than 2, it means that n factorial over 2n is going to be greater than 1 necessarily, because the numerator, this increases, right? The numerator increases while the denominator stays the same. So we're going to separate this, and actually what we're going to do here is we are going to separate it in this way, like here. Let me just going to shrink this and move it down to the side. So, and let me move it a little bit further. Okay. So I have it here, and we can say here that on the left, 1/2 times 2 over 2, this is just 1/2. And this is just 1/2. And all this other stuff here on the right-hand side, well, this is greater than 1, as we've just shown, right? So all this stuff here, this is greater than 1. Okay. And so with this, let us compare to, we're going to compare this to 1/2 times n over 2. Let us compare it, right? And so I'm just going to just copy all the stuff. Over 2 times dot dot dot, n minus 2 over 2 times n minus 1 over 2, I guess I should have made more space, times n over 2, and then I'm comparing this with 1/2 times n over 2. Okay, let's compare it. Well, the 1/2 is accounted for, right? The n over 2 is accounted for, and everything else in between. So all this stuff over here, we can clearly see that all this stuff is going to be greater than 1, right? Because the numerator is greater than the denominator. So we can definitely say that this whole stuff is greater than 1/2 times n over 2. And so since we've established that it is greater, because the only difference between them is that the one on the left has all of this stuff, and as we've seen, all of this stuff here, the numerator is greater than the denominator, so all of this stuff is definitely greater than 1. So all of this is greater than 1. So because all of this is greater than 1, the left-hand side is greater than the right-hand side. And now what we're going to do is we're going to take the limit as n approaches infinity of 1/2 times n over 2, which is the limit as n approaches infinity of n over 4. And this limit here, we have infinity divided by 4. This is just infinity, right? So we can say that that n factorial divided by 2n, this is definitely bigger than n divided by 4, as we have seen, right? And so the limit as n approaches infinity of n over 4 is equal to infinity. So by comparison, if the smaller sequence goes to infinity, well, so does the bigger sequence, right? So by comparison, the limit as n approaches infinity of a of n is equal to infinity. So a of n, it diverges. It diverges, yeah. And so all we've done here is we've shown that a of n, it is definitely bigger than n over 4, right? And n over 4, the limit goes to infinity. And so if the smaller one goes to infinity, then you better make sure, you know that the bigger one also goes to infinity. And so that is how we prove that number 55 is divergent.